Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework. The M&Ms were measurement in different dimensions. This is basically just kind of showing, um, I think I talked about this a little bit earlier in this unit about, why cubic units are to the third power, square units are the second power, linear units are to the first power, and so on and so forth. But this just kind of shows it. When you're just measuring in one dimension, any kind of length, we're just going to use the unit as centimeter, and that technically is centimeter to the first power, being that this is one dimensional. It's only got length. Measurements of area are in two dimensions. You've got a base and a height, you got a length and a width. Two-dimensional means you need some sort of two-dimensional measurement, so that's where we count the number of squares that would fill up that flat plane surface. And because it's two-dimensional, we call it to the second power, or in this case, because we're counting squares, squared. Measurements of volume are three-dimensional. Not only do you have a base and a height, but you also have a depth. So that's where you get your third dimension coming in. And we are now with volume measurements actually taking up space. Lines did not take up any space. Flat surfaces did not take up any space. Points, for that matter, don't take up any space. But three-dimensional objects, cubes, take up space. And so that's the best way to measure them, is how many cubes will fill up that space for any unit of measurement, where it's cubic centimeters, cubic feet, cubic meters, so on and so forth. So the 3 has to do with the number of dimensions that are being multiplied together to find the volume of any given geometric solid. All right, so kind of in line with what we did yesterday, use the pyramid at the right to answer the question. Since the pyramid were sliced vertically, what would the resulting cross sections look like? And so, slicing it vertically, starting at the top and going straight down, what would happen? Let me see if I can draw this in without too much trouble here. That vertical cut would most likely happen here, although they didn't say it had to start at the very top, but that's what I would assume everyone would think. So that's, you got the front side and the back side, which would kind of look like this. And then if you were to slice it horizontally, what is that supposed to be? The back side? I think that's the back side. This is like this front view. This is the panel or the face closest to us, and this one is the one in the back. That one right there kind of looks odd, but that's what it would be. And so, yeah, if we put this guy, this section right here is this section right there. And then if we sliced it horizontally, now this changes things up a little bit. The horizontal cut would be like right here. And so you get this hexagonal prism, right? 1, 2, 3, 4, 5, 6. And it's a prism because you've got two parallel faces that are the same shape, although they're not congruent. So these faces, I think I said that in the past when we were talking about regular prisms, where the two faces that name the prism were always congruent to each other. No, that not all prisms have to have these faces congruent, because this is obviously smaller than the other base, but they are similar to each other, and they're parallel to each other. And so you get the prism on the bottom, and then you just get kind of a shorter hexagonal prism or pyramid on the top. So it originally was a hexagonal pyramid because it had 1, 2, 3, 4, 5, 6 sides on its base, and comes to a point at the top. So this is still a hexagonal pyramid. Now these guys are both pyramids because they both come to a point at the top, and they've only got a single base, and that single base happens to be in the shape of a trapezoid, because that's what you get when you cut a hexagon in half. All right, use the rectangular prism at the right to complete each one of these problems. Calculate the surface area of the prism and show all of your sub-problems. Okay, so because this is a rectangular prism, you know that the front is going to match the back, and the front is a 4 by 12, so you have two 4 by 12 dimensions 4 times 12 is 48. So the combined total area of the front side and the back side would be 96 square centimeters. And then you've got this side right here, which is the right side, which is matched. You've got the left side as well. And this is, oh, wait, hold on for a second. Yeah, I guess that's fine. This would be 3 by 4, right? 4 high, 3 deep, which is going to match these two. So this is the right and the left side. 3 times 4 is 12. So this side has 12 cubic centimeters matched by the 12 square centimeters, I'm sorry, matched by the 12 square centimeters on this side, combine them to make 24 square centimeters. And then you got your top, which is matched by the bottom, and that is a 3 by 12 face. So you've got 2 of those. 3 times 12 is 36. So the top is 36 square centimeters. The bottom will be 36 square centimeters for a total of 72. Add them all together, and they all add up to 192 square centimeters is the total surface area of the entire rectangular prism. So why is the exponent for the area a 2? Well, because the surface area or any area measurements are always two-dimensional. That's what we talked about with our M&Ms. Calculate the volume. Well, the volume is pretty straightforward. If you recall from 6th grade, take the length times the width times the height. So 12 times 3 is 36, and 36 times 4 is going to give you a total volume of 144 cubic centimeters, or 144 centimeters to the third power. That's supposed to be a 4 there. Okay, and then explain why the exponent for the volumes is 3. Well, because it's three-dimensional, right? And we're going to learn some exponent rules in 8th grade that sort of explain this. If I were to change this to be variable expressions, like 4a times 12a times 3a, there is a rule that says when you are multiplying powers together, you'll multiply the number parts together, and so that's how you get your 144, but you also have to multiply the variable parts together. And when you take a times a times a, that is a to the third power, because you're repeatedly multiplying the a's together 3 times. So think of your unit of measurement like you would a variable when we are performing variable expressions and operations and simplifying them. Same idea. All right, James lives in Columbus, Ohio, and wants to know how far he is from Indianapolis. On this map, the two cities are 1 3/4 inches apart. At the bottom of the map, there's a scale. Here's the scale right here. It says that 1/4 of an inch is equivalent to 25 miles. So using this, we're going to figure out how far away Columbus is from Indianapolis. Now, this is not a real easy scale to work with. You could set it up proportionally and figure, all right, how many 1/4 are there in 1 3/4? Because 1 3/4 is the distance between them. And you would see, oh yeah, that's right, there's 7 of them, right? Because 1 3/4 is the same as 7/4. So you multiply this times 7, so that times 7, and that gives you your answer. But some people might change the scale. It's like, why say 1/4 of an inch is equivalent to 25 miles when you could just as easily say 1 inch is equivalent to 100 miles? That seems like a much easier conversion, because you look at it here, 1/100, and then I'll change this to its decimal just so you can see it clearly. What would you multiply times 1 to give you 1.75? Well, that would be 1.75, right? So we'll have to multiply that times 100. And whenever you multiply anything times 100, you just move the decimal 2 places to the right, and we get the exact same answer. So however you decided to set it up, as long as you get 175 miles is the distance between Columbus, Ohio and Indianapolis, Indiana, you are correct. All right, Kenny took some measurements in the front of his house and quickly drew this sketch. However, this is not really drawn to scale. It just looks like your generic kind of a barny kind of a house sort of a look. So our task is to figure out how to draw this properly to scale. So doing this on coordinate grid paper makes things a lot easier. What I decided was I would make each one of these boxes right here, 1 unit will be equivalent to 3 feet. Since 3 goes into 12 4 times, we would need to make this part of the building or of the house 4 units tall. And 3 times 10 is 30. So as long as I make this just a little bit more than 10 units across, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that would be 30 feet. So I'll just go a little bit over, probably not perfectly drawn, but there you go, a little bit more than 30 feet. Now, the trickier part would be using your protractor to make sure that this right here, oops, that this right, what are you doing? Why you do that? Seriously? That's really weird. Okay, let me get rid of all this stuff. So to make sure that this angle right there is a 45-degree angle, because that's what it says up here. And so, you know, you just kind of eyeball it if you want to and figure out what a right angle would look like and try and cut that right down the middle, or grab your protractor and make a little mark at where the 45-degree angle would be and get these two lines, get these two so that they're perfect. But this is basically what it should look like. And if yours looks something similar to this, then you did a great job. All right, I don't know that I want to go through all of these. So here we're in the position where if there was one of these that I did not go over and you really desperately wanted some help on it, send me an email, say, hey, can you do 69E? And I will be happy to work that out for you and send it to you. Bottom line is this: when you're multiplying fractions times improper fractions or fractions times mixed numbers, you got to change them both so that they're improper fractions or fractions. So this one is 16 over 5 times 7 over 4. And then you decide how you want to simplify that. I'll go ahead and do some cross-canceling here. Divide this by 4, divide that by 4, and you end up with 28 over 5, which can then be changed to 5 3/5. Here, when you're dealing with exponents, you want to do that first. And so 5 to the third power is 125 over 1. Multiply that times -4 over 5. And you know you're going to get a negative answer because it's a positive number being multiplied times a negative number. So I'll put my negative sign in. And then what can we divide out here? 5 for each one of those. So this becomes 1 and this becomes 25. So -4 times 25 is -100. So that process applies the same here. I guess in a couple, I don't know. Now we're getting into some exponent and addition subtraction problems. So, oh, and right there you do it. So let me do, say, this one right here. So if I take -4 and raise it to the second power, that literally means, or I should say -4 over 5. That literally means -4 over 5 times -4 over 5. So we're going to get a negative times a negative, which means this is going to result in a positive answer, and you end up with 16 over 25. So now we've got 16 over 25 minus 3 over 50, and we are going to need a common denominator. So I like 50. Let's change that to a 50. So we'll double both the 25 and the 16 to make this 32 over 50 minus 3 over 50, and that's how we get 29 over 50. Here, you got to be careful about doing KFC. Do not add the opposite until after you've done the exponent operation. So this is going to become 9 over 100 minus -2 over 5 times -2 over 5 becomes positive 4 over 25. So now when we do the KFC, we're not adding a positive anymore. Here, we're going to add the opposite. So now we have to change this so it has a denominator of 100, so that becomes -16 over 100. And now for the last step, you will be adding a positive to a negative, which means you're going to do a subtraction because you've got more negatives than positives. So remember the whole integer operations of adding positives and negatives, you've got your 0 pairs. Take away 9 of the negatives from here to make 0 pairs with 9 positives here, and you're left with 7 negatives over 100. Okay, any others you want me to do, shoot me an email. I'll be happy to work those out for you. and then evaluate the inequality. Now, we could solve this inequality, which is what I did here first. If we solve it, we've got an x here and two x's there. So I chose to take away this x from that side and remove balanced sets. So now instead of two x's on the right, you've only got one x. And then at the same time, well, I didn't do it at the same time, but now we want to cancel out this -3 by adding it back in. And so that forms a zero pair there that cancel out just like the x's did. And you now have a 7 here. So what this means, 7 is less than x, also would be a way of saying that x is greater than 7. Remember, think of the alligator eating the bigger lunch, right? X has got to be greater than 7 because 7 is less than x. So which one of these has x is greater than 7? That's the only one that's going to make this a true statement, is when x is greater than 7. So this is the only true statement. This is false because x isn't greater than 7, it's equal to. If we put an equal to sign under there, like this, then x could be greater than or equal to 7, which would make that true in that situation. But there isn't an equal sign attached there, so this is false. The second way that we could do this would be to literally plug these numbers in and see if it makes it a true statement. For instance, if x is equal to 4, then 4 plus 4 is 8. And 8 minus 3 is 5. Is 8 less than 5? No, that's a false statement. And so on and so forth. And that is it. That's our homework. So for those of you that are actually doing your homework and watching these videos every time I post them, can I just say thank you so much for doing your job and doing this work. I've got a terrible headache today, and I don't want to be doing this. But for those of you that are actually finding these useful and appreciate the practice and what that does for your math fluency and understanding, thank you so much. All right, take care. I'm not sure if there's a check for understanding today. I might do a small thing, and then definitely an assessment tomorrow. So take care. Bye.
Hey, feeling good.